get a good understanding of the material we're going to cover today. Okay? First of all, let's talk about similar triangles. Similar triangles are triangles whose angles are all the same. In other words, if I have a 30, 60, 90 and another 30, 60, 90, they're similar because they have the same three angles. And it doesn't matter how they're oriented. This bottom one could be oriented like that. Wouldn't matter as long as it's 30, 60, 90. Okay? And of course, that's where the problem comes in. These aren't hard as long as they're oriented a certain way. But when they're oriented different than one another, then you have to apply a little bit more creative thinking about them. And we'll touch on that. And then also I'd like to go over the Pythagorean Theorem, which I don't know, you probably haven't had a whole lot of Pythagorean Theorem, have you? You've probably gotten it once.
No, I've had it, I used it a lot in 8th grade.
Okay. All right. Good. Good. I want to give you a more...
I can't really remember it.
Well, I'm going to give you...
Right now, but once I probably
no, I'm going to drill. In other words, we might spend the entire half hour today just doing these kind of problems. And the reason is that, like I said, there is nothing more important in geometry than these two principles. Okay. Now, when you have, and notice both of them apply only to right triangles. There's a special category in geometry regarding right triangles as opposed to non-right triangles. Right triangle has to have one 90-degree angle, and it can only have one. You couldn't have two. So they're a special breed. Let's talk about the similar triangles, because that's what we worked on last week.
Yeah.
And what I asked you to memorize, if you could, were the dimensions of the unit similar triangles. These two small ones. I have a reason why I call them the unit. It's because the side opposite the smallest angle is 1. So you get a head start. You know what one side is. So what's the side opposite this 30-degree angle on the left?
The 60, 30, 90 one, or?
Yeah, this little one that I'm pointing to over here. I don't know if you can see me pointing to that or not,
but... move your mouse.
Maybe my mouse will do it where now. Can you see where I'm pointing? You could if I did that.
Oh, yeah, I saw it, yeah.
Okay. What's the side? What is that dimension? Because it's a unit triangle.
Is it a...
1. Hence the name unit. Okay? When I talk about unit triangles, it means always that the side opposite the smallest angle in the triangle is 1. Okay? So that kind of gives you a reference for getting started. This side opposite the 60-degree angle is √3, and this side, the hypotenuse, is 2. Hypotenuse is always the side opposite the right angle. Do you remember what the unit dimensions were of the 45, 45? 9.
It was, I can't remember.
Well, it's a unit triangle, so what does the side opposite the 45 have to be?
One more? Or, I forgot how you get the side.
1. Notice my name, unit. What unit means is 1.
Okay.
Okay, that's the definition of the word unit. So when I ask about my unit triangles, it always means the side opposite the smallest angle is 1. Well, if this side is 1, what's this side, the bottom side here, have to be also?
1.
And that makes this square root of 2. Okay?
Okay.
Okay, and we'll get to the Pythagorean Theorem in a minute, but you could come up with, all of these follow the Pythagorean Theorem. The Pythagorean Theorem says the square of the two small sides added together is the same as the square of the hypotenuse. And that's probably the most important theorem in all of geometry, and that's why you've already come across it multiple times.
Yeah.
Let's not get to the Pythagorean Theorem yet, because in these similar triangle problems, you don't need to use the Pythagorean Theorem. And in fact, it's impossible to use the Pythagorean Theorem. What you need to do is figure out any similar triangle that I would give you, what the similarity ratio is. And once you get the similarity ratio, then you can figure out the other two sides. Okay? So in this problem on the left here, where it's a 30-60 triangle and the hypotenuse is 4, what's my similarity ratio?
The bottom would be
When
3 squared,
no,
right? Or
hold on. Let's do it step by step, okay?
Yeah.
I'm going to ask you about the dimensions in a minute, but I want to make sure you do this in the right sequence. And the right sequence is figuring out the similarity ratio. What is the similarity ratio between this bigger triangle and this smaller triangle? How much bigger?
Twice as big.
That's the similarity ratio. It's 2 to 1. Okay? Now we take that similarity ratio to figure out what y is. What's y?
Y would be 2.
And what's x?
X would be 2 root 3.
Good. And we'll go to a little bit harder one, the middle one. It's also one of the special triangles. It's a 45, 45, 90. And this time I'm giving you a triangle that's bigger but similar. Again, similar means same 3 angles. This is 45, 45, 90. This is 45, 45, 90. What's this similarity ratio? Remember, that's always your first step. What is it?
It's 3 times as big?
No? What is it? How do you get it? How'd you get it before in the previous problem?
Well, wait.
How'd you get a 2 to 1 ratio over here?
It was twice as much.
How'd you know that? You divided 4 by 2. In other words, you started out with 4 divided by 2, and it simplified to 2 over 1. So use the same process. What's the similarity ratio in the middle column? Take the hypotenuse and divide it by the unit hypotenuse. What do you get?
1.5?
No, I don't want a decimal. Here's what I want for an answer. 3 divided by root 2.
Oh, yeah.
Okay? That's all. That's your similarity ratio. Now, it's true that, and I'm sure you've probably been taught this, that you're not supposed to have an irrational number in the denominator. And so I would never give this as a final answer. But as an intermediate answer, it's perfectly fine. There's no difference between this and a number that's been rationalized. And if you don't know what that means, we'll get to it later. Don't worry about it. So this is my similarity ratio. It's merely the length of the larger triangle, the same side, the hypotenuse, divided by the length of my unit triangle. That's all it ever is. Okay? But now, once you get that similarity ratio, you can figure out the other two sides. What's y?
Y would be, let's see,
you're going to multiply the similarity ratio by this number right there. What's anything multiplied by 1?
Whatever that number is.
Exactly. So 3 divided by root 2.
Yeah.
And the same for x. X is also 3 divided by root 2. Now, I could spend a lot of time saying what we need to do to that answer to make it more presentable, but I'd rather not do that today. That's more algebra than it is geometry. What I really want to get into is the Pythagorean Theorem the rest of the time. And you'll see that we could use, we could use the Pythagorean Theorem to solve some of this stuff that we've been doing the easy way. Okay? But the Pythagorean Theorem is a squared plus b squared equals c squared. And that applies to this right only, incidentally, to right triangles.
Oh yeah, I remember that, yeah.
But they don't have to be special. In other words, they could be 29 degrees and 61 degrees. As long as they're a right triangle, then a squared plus b squared is going to be equal to c squared.
Yeah.
So how would you solve this particular problem? This is a right triangle. One side's 2. The other short side is 3. The way I refer to right triangles is they have 2 short sides and they have 1 hypotenuse.
So it would be 4 plus 9 equals 13 squared.
Well, let's call it z squared, right?
Yeah.
Because that's what you did, is you took this side, squared it, added it to this side, squared, and it's got to be equal to that side squared. Now solve for z. In other words, now I have 13 equals z squared. What's z equal to?
We got to divide by z now.
No, you don't divide by z. Take the square root of both sides.
You have to find the square root of 13?
That's the answer. Okay. Let's talk about that for a second, because that's a very common problem and I want to make sure you don't make it. If I have, if I have z squared equals 13. Now, you weren't that far wrong by dividing by z, because you accomplished the biggest goal, which is to get z all by itself, right? That's what you're trying to get.
Yeah.
But the problem is that you have z on the other side of the equation also. And that is never a solution for z. This is not a mathematical solution for z.
Yeah.
So the only time you solve an algebraic equation is if you've got the variable all by itself on one side and nothing but numbers and or other variables on the other side. But if you have any z on the other side at all, that's not the way to go. Okay? So, I don't want to divide by z, but if I take the square root of both sides, I end up with z all by itself on one side, and I have the square root of 13 on the other. Now technically I have plus or minus the square root of 13, but once you get into geometry, it's easy to forget the plus or minus because all dimensions are positive. So in the problem that I gave you where one side was 2 and the other side was 3, that's only root 13. It's not plus or minus root 13. Okay, so normally in math, I'm a firm believer that you should learn the primary equation, and that's all that you should memorize. In other words, you don't want to memorize derivations of it. The one exception is the Pythagorean Theorem. Okay? And the reason is, for that one exception, is that you're going to have to do this thing 500 times also over the next 3 years, believe it or not. I mean, it's going to be hard for you to believe how often you're going to have to do this. So, in this particular case, I actually advise my students learn how to solve for either the hypotenuse or one of the short sides. Well, what's the hypotenuse? The hypotenuse is equal to that, if you just do the algebra.
Yeah.
And one of the short sides, A, is equal to the hypotenuse squared minus the other short side squared. Or the other short side is really easy to remember because it's the same thing. It's the hypotenuse squared minus the other short side squared. So when you're solving right triangles, I definitely believe that you are 5 steps ahead of everybody else if you can memorize these. You really only have to memorize 2 of them, right? I mean, I don't need to memorize this third one. It's the same as the second one, only it's the different short side. Okay, and let me draw the picture just so you know what I'm talking about. This is C, that's A, and that's B.
Yeah.
All right, so let's do some drill. I'm going to give you a triangle with 2 out of the 3 sides. I want you to solve for the other one. Solve for C.
Okay.
And I want you to do it using these 2 things that I have check marked here.
The answer is 5.
Good. Notice that triangle is a 3, 4, 5 triangle. That happens to be also a very, very, very special triangle. It is the lowest whole number right triangle. There is no 1, 2, 3. There's no 2, 3, 4. There's nothing smaller than 3, 4, 5. And in fact, the next biggest one, they call these perfect Pythagorean triangles. The next one is this one, 5, 12, 13. And these 2 triangles are also very, very special, and you should look for them. If you were to take the ACT test or the SAT test, tomorrow, half the triangle problem, no, 80% of the triangle problems would be either a 3, 4, 5 triangle or a 5, 12, 13. In other words, these are two more triangles that you're just going to deal with over and over and over again. How about this one here? Notice I don't know any angles here. In other words, it's definitely not a 30, 60, 90, and it's not a 45, 45. I'm sorry, I should always put the little right angle thing there, because that tells you it's a right triangle. So let's see in this one. Plug it into that.
It's the square root of 13.
Good. Let me make that say, instead of x, let me make it say a. What's a?
A would be, the square root of 10.
Plug it into this formula right there.
Well, yeah, because c squared is 7.
What's c? What's c squared?
Whoops. Square root of 45.
Good. Now, that's not an acceptable answer also because it can be simplified.
Yeah.
How do I simplify that?
It would be...
We'll do a little bit of algebra. We won't do totally geometry. You can't forget all your algebra because half of geometry is algebra. And I'm not kidding, at least half. What you do is you take all these graphs and triangles and circles and you convert them to equations and you have to solve the equation. So we got to make sure we keep you current on your algebra. Find factors of 45, one of which is a perfect square number. So what is it going to be? It's the square root of something times the square root of something. In other words, anytime I have this, I can always factor the number that's inside the radical and put each factor there, and it's the same thing. So what are factors of 45 where one of the factors is a perfect square number?
I can't remember right now.
All right, let's go through how you find factors. Because some people are not real strong on this, and your calculator does not help one bit. So factoring numbers is something you want to learn how to do if you don't know how to do it already. First thing I always try to do is, can I divide that in half? Well, no, I can't.
No, but you can divide it by 3 and it's 15.
Okay, which means if I divide it by 3, I got to multiply the other one by 3. Now, let's keep going. Can I divide 15 in half? No, but I can divide it by 3.
There's 5 and 9.
Okay. I finally found a factor that has a perfect square number in it.
Oh, yeah, I remember this from algebra.
Okay. So that's what I want to do. I want to make it 9 and 5. Yeah. Square root of 45 is the square root of 9 times the square root of 5. And the reason I want to do that is because I can turn that into a whole number. That's 3. So it's 3 root 5.
Yeah, 3 root 5.
And that's the answer I would put here, would be 3 root 5. If you put that answer, you would lose points. You might get some credit from your teacher, but you would not get full credit. Always want to give simplified answers. Now, having said that, if you put that into a calculator, you're going to get exactly the same answer as if you put that into a calculator. So they are the same number. The only reason you wouldn't give full credit is because there's a convention in mathematics that you always give your radical answers in simplified form. So we're always going to simplify this, if we can. Now, let's talk about that for a second. What is the square root of 10 equal to? It's simplified. I can break it up into the square root of 2 times the square root of 5, but that doesn't do any good because neither one of these are perfect squares. So I end up merely with 2 terms rather than 1. So the only time you ever simplify it is if you can break it up. Okay, square root of 8, what's that simplified to?
2 and 4, which would be 2 root 2.
Exactly. So square root of 8 always simplifies. Square root of 6 never does. Square root of 10 never does. And the square root of any prime number never does. All of these are in simplified format right here.
Yeah.
Okay. And since we got 1 or 2 minutes, let's talk about some other math conventions that I bypassed earlier. We had one answer that was this. Okay?
Yeah, don't you multiply both sides by 3?
By root 3.
Yeah.
And we're not really multiplying both sides. What we're doing is multiplying the top and the bottom. And what we're really doing is multiplying by the number 1. You can always multiply a fraction by the number 1 and you don't change its value. What you do get is 2 root 3 in the top, and in the bottom you get 3. Now, this may not look any better than this, but it's a lot better. And there is another convention in mathematics that says you do not divide numbers by irrational numbers. Well, that's an irrational number. That's a rational number. I don't care if I have an irrational number in the numerator. That's okay. But you just don't leave irrational numbers in the denominator, or at least you don't leave radical irrational numbers in the denominator. If I had 2 divided by pi, there's no way to rationalize that. That's my answer, even though that is an irrational number. I can't rationalize pi. There's nothing I can multiply this fraction by to turn that denominator rational. But whenever you have irrational numbers that come from radical signs, you can always rationalize them by multiplying the top and the bottom by whatever's in the bottom.
Yeah.
All right. It's a good session. We'll do more Pythagorean Theorem triangle stuff next time.
Okay.
Okay? All right, Daniel. Talk to you next time. Have a good one.
Yeah. You too. Bye.
Bye-bye.